Right now, your life is connected to things you can't see. GPS satellites above your head, internet signals crossing the sky, power lines stretching across entire countries. And the sun can break all of it, not by burning the earth, not by exploding, but by throwing a storm of energy into space, one powerful enough to make satellites fail, radios go silent, and power grids collapse. You wouldn't feel it hit. Your phone would just lose signal. The lights would go out, and one by one, the modern world would start switching off. This is what could happen if a massive solar flare hit Earth, and the storm that follows it. And the scariest part? Something like this has already happened before. Let's start with the thing almost everyone gets wrong. A solar flare is not going to burn you alive. It's a sudden explosion on the sun's surface, a burst of radiation, X-rays, and ultraviolet light, racing toward us at the speed of light. It crosses 93 million miles in about 8 minutes. But here's the part that should surprise you. Your body is safe. Earth's atmosphere and magnetic field absorb that radiation long before it reaches the ground. You could stand outside during the most violent flare in history and feel nothing at all. The flare doesn't hurt people. It hurts machines. And in a world that runs entirely on machines, that is so much worse. Because a big flare rarely comes alone. Often it's followed by something far heavier, a coronal mass ejection, a CME. Picture 1 billion tons of magnetized plasma blasted off the sun. Not light this time, but matter. A cloud of charged particles dozens of times the size of Earth. The flare's radiation reaches us in 8 minutes. The CME is slower, usually 1 to 3 days to cross the gap, which means, in theory, we get a warning. But knowing a tidal wave is coming doesn't drain the ocean. And when that cloud slams into Earth's magnetic field, it does something you'd never expect. It reaches down and pushes electricity through the ground itself. Here's how it kills the grid. When the storm hits, it makes Earth's own magnetic field shudder. And a shifting magnetic field generates electric current in any long piece of metal. Power lines, pipelines, undersea cables, railway tracks. Engineers call these geomagnetically induced currents. Your power grid was never built to carry them. We've seen exactly this before. September 1859, the Carrington Event, the most powerful solar storm in recorded history. The CME crossed to Earth in just 17 hours. Back then, the only electrical network on the entire planet was the telegraph. And it was enough. Telegraph lines threw sparks. Some offices caught fire. Operators were shocked at their desks. And, in a detail that sounds impossible, some operators disconnected their batteries completely and kept sending messages using only the current the storm was forcing through the wires. Auroras burned as far south as the Caribbean. People woke at midnight, convinced it was dawn. In 1859, that storm struck a world of wire and paper. Now imagine it striking a world of microchips. And you don't have to imagine the grid part. It already happened. In living memory. March 13th, 1989. A CME hit Earth's magnetic field. 90 seconds later, the entire power grid of Quebec, Canada collapsed. Not a city, a whole province. 21 gigawatts of power, gone in under 2 minutes. 6 million people lost electricity for 9 hours in the freezing dark of a Canadian winter night. The storm overloaded transformers, tripped breakers, and tore the system offline. And it didn't stop at the border. Hundreds of grid faults rippled across the United States. At the Salem nuclear plant in New Jersey, a massive transformer was damaged so badly it had to be replaced entirely. And that was not a Carrington-level storm. It was a fraction of one. And it still erased a province in 90 seconds. Now here's the part that should genuinely unsettle you. In July 2012, the sun fired a Carrington-class superstorm straight through Earth's orbit. A monster. As strong as 1859. It missed us by about 9 days. The only reason we're fine is that the spot it erupted from happened to be facing the wrong way. Earth had simply already moved past. A NASA scientist who studied it said we were incredibly fortunate. We didn't survive because we were ready. We survived because of luck and timing. And these storms are not rare on a cosmic scale. Scientists estimate a storm this size has a real chance of striking us in any given decade. And the last direct hit was more than 160 years ago. So what actually happens if a big one hits us, head on, today? It wouldn't look like a movie. No explosions. It would be quieter than that. And far worse. First, within minutes, the flare's radiation floods the upper atmosphere. GPS signals drift and fail. High-frequency radio, the kind planes rely on over oceans and poles, goes silent. Flights get grounded or rerouted. Then the particle storm reaches the satellites. We have thousands of them now, quietly running navigation, weather, banking, and communication. A storm can fry their electronics or drag them out of the sky. In February 2022, a minor storm, nothing close to Carrington, thickened the upper atmosphere just enough to pull around 40 brand new Starlink satellites back to Earth within days. Then, a day or so later, the CME arrives, and the grid becomes the real catastrophe. The transformers are the weak point. The giant ones that move power across continents are custom-built, each one unique, weighing hundreds of tons. They are not kept in stock. Only a handful of factories on Earth make them, and a single replacement can take a year or more, shipped on a specialized rail car. A severe storm could destroy dozens of them at once. And here's the cascade almost no one thinks about. No grid means no water. City water runs on electric pumps. No fuel. Gas pumps are electric. No refrigeration. No card payments. No cell towers once the backup batteries die. The U.S. National Academy of Sciences estimated that a Carrington-scale storm today could cost $1 to $2 trillion in the first year alone, and that full recovery could take 4 to 10 years. 4 to 10 years. To rebuild the thing you switch on without a single thought. And this is the strange truth the sun is trying to teach us. We think of ourselves as advanced, protected, untouchable. But the more wires we string, the more satellites we launch, the more we plug every part of our lives into one invisible electrical web, the more we have to lose. In 1859, a Carrington storm was a light show and a few burnt telegraph offices. The same storm today could switch off a civilization. The danger didn't grow because the sun got stronger. The sun is doing exactly what it has always done. The danger grew because we did. The flare will never touch your body. It can't. It goes after something else. The fragile, invisible nervous system we've wrapped around the whole planet and quietly agreed to depend on. The sun has fired these storms for billions of years. It will fire another one. We don't know if it's 100 years away or next Tuesday. And when it finally hits us head on, the sky will glow with auroras more beautiful than anything you have ever seen. You'll step outside to watch, and one by one, behind you, the lights will go out.